welcome to the DataPains channel. My name is Simon and I work as a lead data engineer day to day at the moment. Today I want to share some experiences with hosting and deploying Airbyte. So what is Airbyte? Well, according to Airbyte, they're a data movement platform. And most of you who have heard about Airbyte probably recognize it for its low-code capabilities. However, that's not all it does. Airbyte supports no-code, low-code, or customized connectors where you can write your own custom logic. Similar to what you might do in Airflow, where Airflow is the orchestration tool and then you have to write your own operator. Well, in Airbyte you can do something similar, but Airbyte does not work in a DAG fashion. For me, I was looking for a clean extract load process, essentially low code. I didn't want to have to write a code base to move very basic data flows. And also some of these basic data flows can get a bit complicated in terms of, if it's incremental or a refresh or whatever it might be. And then it was very important to me to use something that doesn't lock you in. And there's plenty of other tools there that I won't mention, but that essentially cost a lot of money. Also the fact that the data community was talking about this quite loudly. A lot of people were mentioning this way back when I was discovering it. And also the fact that I just wanted to avoid Airflow at all costs. So the Airbyte architecture is pretty, I wouldn't say light-hearted, but it's decently straightforward. And depending on who you are, if you're watching this video, you're most likely going to run Airbyte yourself. You don't need to know every single component, but it does help to understand this. Since I started out hosting Airbyte vanilla style, I had to go through each component and to understand what was going on. And since Airbyte is, well, when I started out using Airbyte, it was still early on and they were adding and removing stuff back and forth, which made it a bit painful to upgrade. However, at this point, they have a very stable Helm chart, which I recommend you use. Anyway, some of the core main concepts of the architecture, low level, is that you can create source or destinations through the UI. They also have a Terraform provider. Through the API, essentially the Terraform provider communicates through their own API, and this will trigger essentially creation of different tasks through a worker, and the worker will spawn it will spawn the source checkers. So that's a pod that comes up and checks that the source is actually correct or it's working and it's still valid, like a Postgres database, making sure that the connection is still there. And then it will spawn a source read, and that will be your source reader that will grab your data, either if it's CDC or in xmin or whatever it might be. And then after that it will spin up a destination checker and a destination writer, let's say S3, and it might spin these up in parallel to each other. The order of them are, I wouldn't say super strict. I've been trying to look at how they run and how they behave, and the reader and the writer can run in parallel to each other, but you can't have, for example, multiple readers at the same time and multiple writers at the same time. Airbyte will always just work with one source reader and one destination writer at the same time, which kind of makes this a little bit slow at times, but it works. And also worth mentioning that Airbyte uses an internal metadata database, in this case Postgres, by default in Kubernetes. You can also use an external one where it stores all the information around when something's about to be synced, the status of that sync, etc. and it uses min.io for logs, and you can also use an external like S3 bucket for this. But yeah, I recommend you go and you check out the documentation to see this even further, but on a high level. So the core concepts of Airbyte are essentially that you have a source, you have a connector that will read from the source, and you will have a destination connector to write to your destination. And together, when you set up your source and destination connector, you get a connection. However, please read the documentation for more low granular details. Well, what do I like with Airbyte? Well, it's a big open source community. It is designed for Kubernetes, which is very easy to replace Airbyte if you don't want it any longer. I used Airbyte primarily to move Postgres data into raw Parquet files. I started out by using a simple incremental approach with a cursor given an updated at timestamp column. So in my use case, I could not use CDC from the beginning because of various different reasons, and essentially I used this incremental approach, and it was great. However, every time any data was added without this updated column being updated at source, I would miss it. And if I, for whatever reason, needed to do a full reset of the data, if the sync failed in between it was trying, it would simply be lost, and it would have to restart all over again. So for very big tables, if the resources were not aligned for what you were trying to do, the whole thing could die 1 hour in, 1.5 hours in, and you would have to start over all again from the beginning. To solve this, I started to use something called xmin, and essentially this is a very efficient way of picking up data from the Postgres database, no matter what operation it was, except deletes. So I had a soft delete process after Airbyte due to this. So if you had CDC, you would have been able to pick it up. And Airbyte specifically tells you that if your data is larger than 500 gig, you should be using CDC, and for delete events. Well, I managed to get it working anyway due to some other workarounds. So what I don't like with Airbyte is the resource management. This is something that is not very well defined either in the documentation or in how you're setting it, and I will show you shortly why. Another thing that I don't like with Airbyte is that it's quite slow. Essentially, it's not distributed, at least not for Postgres and S3 source and destination connectors. It's not multi-threaded, so that is also another thing where when you're doing syncing, it will take a long time, and it's not just about hammering resources. There are limitations by design. However, you could work around that, I assume, by writing your own connector. But I'm just speaking from the open source, well, the completely open out-of-the-box ones, particularly Postgres 1 and the S3 one. So another annoying thing with Airbyte is the resource management for source and destination connectors. When you configure this for jobs, it will be exactly the same for both. So let's take an example where the writer needs 8 gig and 2 CPU, but the source reader only needs 2 gig and half a CPU. Also, there is barely any documentation that's useful. You will have to do a lot of digging around the SOCAT and the sidecars in general. There's a few, but it's barely documented, and I spent a lot of time figuring this out. I will put a link or a comment where I highlight which parameters you should think about. And yeah, to highlight, I will link the URL where you can find the documentation around these job parameters. But as I said, they don't cover all of it. So, should you be using it? Well, if you're already utilizing Kubernetes as your main platform for deploying applications, it's pretty great. Also, if you don't need or if it's important to you to not be locked by a vendor, by some of these other low-code tools, Airbyte is by far probably the best choice. I would also say that Airbyte is great when it comes to extract and load. If you need to do a lot of transformation, I know they keep saying on their website and they have all these capabilities, etc., but it doesn't come easily out of the box. You will have to spend a lot of time doing that. So then a lot of people might just, write their own custom logic outside of Airbyte. So I think the big value in Airbyte is the extract load capabilities, connecting to a source quickly, writing it to a destination, not doing much with it, but keeping it simple. And also, performance. If performance is not your main concern, at least from my perspective, Airbyte is fine. But like if you're looking to build a very low latency streaming platform, I mean, I know Airbyte uses CDC and they use Debezium under the hood, but I would just run Debezium by itself. If you only need that, then you don't need all of Airflow. There's a lot of stuff running, utilizing resources for no reason. So think about this as well. Like in my case, I had a lot of potential up and coming sources that I wasn't aware of 100%. So Airbyte was a good fit. I ended up maybe using 1, 2, or 3 different sources, but always the same destination in my case. So, but it was still useful for sure. And yeah, as I said, if I was going to use, I would definitely use it again. I would, however, deploy it in Helm. I would not go through the vanilla Kubernetes route anymore. However, I don't regret it because I learned a lot by doing that. And I recommend to anyone who's starting out with Kubernetes to learn the basic concepts, to deploy stuff from scratch, vanilla style, before jumping into Helm. Because if you don't know how Kubernetes works and you use Helm, Helm is kind of a black box interface that wraps logic and you just define configuration in a YAML file and you don't really know what's going on. So, but still, I would recommend using Helm. I would also utilize Argo CD for this. It's perfect and it manages it in a really good way. I have another video where I do this, so check that one out. And if I could, I would also have been using CDC from the get-go. However, I just couldn't. Sometimes some things are out of your control, and you can't change that. And I was syncing to raw Parquet, and that is because I was loading the data into Delta. So I had a Spark job that would read all these raw Parquet files, it would do soft delete checks, write them into Delta, and then they would go downstream into either a batch or CDF, change data feed, streaming or event-based transformations. However, now with the latest Airbyte, the community has created a Iceberg destination connector, which is pretty awesome. So that means that you can just go straight from source to Iceberg. You can then use Spark or Trino or whatever directly on that source, which is pretty awesome.